Hello, my name is Sebastian Pirch. I make this video tutorial to introduce you to the features of Game Engine, which is a set of tools for pure data, and it was designed to make working in 3D space easier. So we start here to create the game window, and as you can see we have helpers like the grid and this middle point to give you reference points, otherwise the game window would be just black. And we start with the most basic and important feature, the navigation. With your left mouse button you can orbit around the target point, this little red dot here. With the right mouse button you can zoom in and out, and with the middle mouse button you can pan, which means to move the camera and the target point normal to the viewing vector. So with this you can navigate around, move around in the 3D space, and the trick is to do this with the pan function. You go here, if you want to reach the middle point from here, you rotate normal to it, and then you can pan to it and zoom and see if you're there. Here we have a slider for the field of view, and here we have a knob for the roll angle. A virtual camera needs three things to work. The first is the position of the camera itself, which is here in the first row. The second thing is the position of the camera target, which is the point where the camera looks to, which is here in the second row. It's both x, y, z coordinates. And the third thing is the up vector, which defines the up direction of the camera. So if I just orbit the camera, only the first row changes, as you see. When I pan, both of them change, and when I change the roll angle, the third row will change. So the first two rows are points, and the third row, it means a vector, which is the green thing here now. It's the so-called up vector. These sliders here are for the background color. We have one for the brightness and individual controls to make colors. This yellow toggle is to turn lightning on and off. And the lights themselves are in here. You open the game window, you get this. This is one light, it's hard to see now. So I can change the rotation of the light here, and so it comes from another direction. We have two here, one yellow one and one blue one. And you can change the intensity of the color of the light here. We also have a control for fog here. So you see, these are different fog modes, and this slider controls the density of the fog. This small cube in the middle has a side length of 1 meter, and the big one has a side length of 200 meters. Then we also have grid, the mouse cursor, which I will come to later, and some text which tell you which side you are looking at. Then the next thing is the preset buttons here. It's presets for the camera view. This one sees from the top, this one from the right, this one from the front, from the back, this from the front, left, bottom, and so on. Here you can hide and unhide the scene helpers. There is several of them. The camera target, the center. This cube represents a volume of 1 meter. This one smooths the camera motion. You see? It's delayed. And this one turns the navigation on and off. So nothing is happening here. This one is off. The next important thing is the cursor. It's the white dot that follows my mouse. It is used to select objects, for example. If we subtract the position of the cursor from the position of the camera, we get a ray which we can use to select other objects by comparing their unit vectors. It comes out here that its name is CCView. This is pretty much it for the first part. We move now to the example files section. The first thing you will have to do is adjust this path so the patch finds the example files, and then we start with select object. Which introduces some algorithms for selecting objects in 3D space. So you see, we can click on these cubes and they report their ID number. Also, if one is in front of the other, it will always choose the most front. There is more explanations. Just open the patch and look at my commands. Another thing I have made here is you can select some objects and press the M key on your keyboard to move them around. So this provides basic interaction with things in 3D space. Now we close this and open something interesting. It's called Agents. Now look for this. Here we have a nice 3D model, the OBJ. The patch itself looks like this. First thing to do is click this here, like this 2 times, and then this, and we see many people get created, and they run around on the surface obeying several rules. And these rules are defined by mappings. Easy to say. So we have one mapping which defines where these guys are allowed to go and where not. It looks like a moment. It looks like this. They are allowed to be in the white areas, but not in the black ones. If we see this from the top, you can see that this thing here is here, and the other black things represent walls or houses. The next rule they obey is that they move along the surface, and this is done by a height map which I exported from Swedish Maps. It looks like this, and the gray value stands for a specified height. You can also see that these dials turn red and stop. This is the collision detection, which also works with a mapping-like system. Every agent writes his actual position in an array, and before he goes somewhere else, he checks if that field of the array is free. Otherwise, he turns around and goes somewhere else. And so it's not possible for two agents to be in the same field of the array. This is a quite advanced example, but look at the documentation. And now we also have a file named Arrow Navigation, which works together with this. It simply enables us to use the arrow keys of the keyboard to go through this like in a computer game. And you see it also follows the height map like the agents do. It does not follow the space map or the collision detection tool, but this could be easily implemented. The last thing is a tool for character animation. It's called Pipet, like in Swedish Max. It looks like this. We have a timeline here, and we have our puppet here. It uses a coordinate list which was exported from Swedish Max, and by this we can import character animations into them. See, this happens by this represents the whole list of coordinates. Yeah, this was it for the beginning. I hope you liked it, and stay updated on my blog, and have fun.